Good day. Welcome to video number 14 of the series Mastering the INCOSE System Engineering Handbook in preparation for the INCOSE System Engineering Professional Exam. This video number 14 in the series is about the maintenance process, chapter 4.13 in the System Engineering Handbook. My name is Lance Sherry and I will be your tour guide for this video. So the System Engineering Handbook has encapsulated processes and activities, best practices for system engineering of complex systems in complex life cycles. The System Engineering Handbook has 59 processes and activities, and these 59 processes and activities are categorized into 7 groups. The one group is the technical processes group, and these are all of the activities associated with the System Engineering V. This video is about the maintenance process. That's the second last process before disposal. To put things in the context of the system's life cycle, the maintenance process, also known as the support stage, runs in parallel with the utilization stage. So the system has been validated and now it's in operation or in utilization. It's owned and the responsibility is that of the operators. And while the operators are performing services using the system has to be maintained or supported. And that's what this process is about. The learning objectives for this video is the purpose of the maintenance process, outputs, inputs, and process activities. And then there's a breakdown of the different types and methods for maintenance. So there's the types of maintenance, the levels of maintenance, preventative maintenance techniques, and maintenance enabling systems. So let's jump right into it. The System Engineering Handbook defines the purpose of maintenance process is to sustain the capability to provide a service. So note this is conducted concurrent with the operations process. So this is making sure that the operations process can work effectively by maintaining the system. In simple language, it is intended to prevent breakdowns, and when breakdowns do occur, to repair breakdowns. So on the right-hand side, you can kind of see the 3 types of maintenance. One is something breaks and you have to correct it. So you'll identify the broken part and replace it. 2 is to take preventative measures to change things before they break down. And then the last kind is to upgrade the system for system-wide improvements. So as inputs to the process, you would imagine that you would need the system itself that's to be maintained, and then supported by training material, personnel, equipment, parts, and so on. To perform the activities, you have to follow the manuals that are provided and to perform the maintenance. And then lastly, what comes out the back end is the maintained system itself, the maintenance procedures, and the maintenance records. So with regards complex, safety-intensive systems, maintenance records are really important because this is the way that you can go back and demonstrate that the maintenance has been kept up. And also in the event of an accident or an incident, the authorities can go back and look at the maintenance record and see to what degree maintenance played a role in the accident or incident. So not a very complicated process in terms of the way it fits into the life cycle or the purpose. So let's take a look at the types of maintenance: corrective, preventative, and system upgrades or system modifications. So corrective is to restore the system to normal operations. Preventative maintenance is scheduled routine maintenance operations designed to sustain optimal performance. And then system modifications are upgrades. Levels of maintenance is the term that's used in the System Engineering Handbook. And this kind of identifies who does it and where they do it and how complex the maintenance is. The first class the handbook defines as user operator maintenance. And that has to be a routine, simple maintenance performed by the operators, typically in the field. In situ maintenance, repair, or field maintenance is performed by experts, and that's typically when the system is broken down. So the system fails, can no longer operate, and so the field maintenance department has to send people out to repair the situation. And then factory maintenance is for the purpose of upgrades, and that's where you would bring the system in to a depot and perform upgrades. In theory, too, the maintenance, factory maintenance can also be used if a system breaks down, and then the system would be towed or somehow transported to the depot for maintenance. So user operator, simple out in the field. In situ, more complicated, requires some expertise, also out in the field. And then factory maintenance is at the depot. The biggest way to reduce maintenance costs and to increase utilization, to keep the system operating for the longest time possible, is preventative maintenance. And there are three kind of classical techniques for performing preventative maintenance. One is condition-based maintenance. So in that case, the sensor provides cues to identify the status of the system. And when the system starts to degrade, the sensors pick up that data and send an alert, and then the system can be repaired or maintenance performed based on the condition. The reliability-centered maintenance, RCM, is similar. It improves reliability while reducing downtime by performing routine and preventative maintenance. So really trying to maximize the overall reliability of the system. And then the third is performance-based lifecycle product support. This is a slightly different way of thinking about maintenance. The equipment provider will guarantee performance for a number of operations. And so they will do, and therefore they're incentivized to build systems, design systems that require the least amount of maintenance activity, because then they can charge more for their product and they can get more out of the existing product. So an example of that is with regard to aircraft engine manufacturers. They will sell their product, kind of rent their engines to the airline, and they will guarantee them a certain performance level without maintenance requirements. If there is maintenance required, the engine manufacturer will pay for maintenance and cover the maintenance. So those kinds of maintenance are known as power by the hour. So you instead of just selling an engine, say here it is, use it, maintain it according to our standards. You say here's an engine, and by the way, we're going to guarantee this much performance over a period of time. And if there is any maintenance required before that time, then it's on us. Of course, in order to perform maintenance, you've got to have personnel, and those personnel need to be trained. You need technical data, manuals, etc., facilities and infrastructure, and then the maintenance planning and has to be planned and managed appropriately. The fourth item is sustaining engineering, and this is the idea of continuously monitoring the system's performance out in the field, and then making preventative maintenance and corrective actions in the event that they're required. So that's the list of maintenance enabling systems. So this is the time in the video where you can take a step back, get a pencil and paper, put the video on pause, and see if you can answer these questions. And then here are the answer to the quiz questions on the maintenance process. So thank you again for participating in this series. This video is about the maintenance process. The next one is the disposal process, and we'd be grateful if you could give us a thumbs up. Thank you.